So what we're looking at in 10.2, these are called linear functions. Let me see, find my little boundary here. Now, what linear functions are? They're functions that look something like this, where m and b are constants. So we treat these like the same functions we had in the last section. So you can generate points using these. For example, let's say we have something like this. So f of x equals 4x plus 7. Well, we might be interested in computing f of 2. So this will become 4 times 2 plus 7. And again, we do the multiplication first. And that's going to give us 15. So if we wrote this as an ordered pair, remember for ordered pairs, input is first, then output. We get 2 and 15. So these are linear functions. And when we graph these, what we're going to get every single time is a line. So is it okay if I erase this?
Yes.
All right. So their graphs are lines. So to graph a line, you need really just 2 points. So to graph a line, you need at least 2 points. Now, in the homework, I think they do have problems where they'll have you graph with 3. I think sometimes they do have you graph with 3, but you really only need 2. 2 is going to be the necessary minimum. So for example, let's say we have this. So we want to generate 2 points. And I typically recommend do this kind of easily. You pick numbers that are easy to work with. So let's say we have an input of 0. We'll let x be 0. And that'll give us 2 times 0 plus 1, or 0 plus 1, or 1. And so the input was 0. We have an output of 1. Now let's look at say f of 1. So the input's going to be 1. Output is 3. So with these 2 points, we can graph this function or this line.
Can you bring the camera down just a little bit, please?
Oh, yes, here, I can scoot this up. Is that better?
Just a little bit more, please.
Got it. Is that better?
Yes, thank you.
Awesome. Now, to graph these points, we have 0 and 1. So we start at the origin, and well, we go to x is 0. Well, that's right here at the origin to begin with. Then we go up to y is 1. It's going to put us up here. I'm going to grab a different pin here for that. Now for the second point, 1 and 3. So we start at the origin, we go to x is 1, and then we move up to y is 3 from x is 1. And that gives us our second point. And then using these 2 points, we draw our line. And so this would be the line f of x equals 2x plus 1. So as far as graphing these go, if you know how to do that, you're going to be fine. You can graph any of these functions. What we're going to look at now are different ways you can do this. Sort of depending on what you're doing, might be easier. Sometimes it might not be. Sometimes it might not. But hopefully, these are techniques that are going to be easier. So any questions about that? So what I'm going to talk about now are intercepts. So you have 2 types of intercepts, an x-intercept and a y-intercept. Now we have our x-axis. That's our horizontal axis. And we have our y-axis, or the vertical axis. So when we graph a line, if it crosses over the x-axis, at that location, we have an x-intercept. And then if it crosses the y-axis, at that location, we have a y-intercept. Now, there's a special property that goes with each intercept. And we can use this property to help draw lines, because as you can see here, this forms a point and that forms a second point. So if we have the X and Y axes, and if it's a point that crosses a line that crosses both the X axis and also crosses the Y axis, in other words, well, we can graph this line. So now, that being the case, well, let's look at those properties. So basically, it's going to work like this. For an x-intercept, this will have the form of a, comma, 0. In other words, for the x-intercept, the x-coordinate is going to be a, but the y-coordinate is always 0. So how do you find this? Well, what this says, well, first, let y equal 0. So this is how we're going to find the x-intercept from using a linear function, f of x equals mx plus b. And then we're going to solve for x equals a. Now for the y-intercept, it always takes this form. The x-coordinate is 0, and the y-coordinate is b. So to find the y-intercept, we first let x be 0, and then we solve for y equals b. So we're going to work with an example here. We're going to go through and find an x-intercept and a y-intercept for a linear function. But this is how we're going to do it. For the x-intercept, we'll let y be 0, and then we solve for x equals a. For the y-intercept, we'll let x be 0, and solve for y equals b. So any questions about that before we bring these to life? All right. So let's say we have this. Now, the problem with this is we have an f of x instead of a y. So we can make f of x, we can call it y. They play the same role. The value of y will depend on what we choose for x. Same with f of x. This symbol, its value will depend on what we choose for x. So this gives us y equals 3x minus 9. So first off, let's look for the x-intercept, and I'll abbreviate intercept. So first off, to find the x-intercept, we let y be 0. Then, with y equal to 0, we're going to solve for x. In fact, let me write this a little differently. And we divide by 3. And so we get 3 is equal to x. So we've got 3 equals x. We started out with y equals 0. So this means the x-intercept is going to be 3, 0. I'm going to write it off to the side here. So any questions about that? All right. So now we need to find the y-intercept. So again, I'll abbreviate intercept. Now for the y-intercept, we start out with x being 0. That's our first step. So what that means is that if x is 0, y will be 3 times 0 minus 9, or y equals 0 minus 9, or y equals -9. So for y-intercept, we always start with x as being 0, and we solve for y. And so the point will be 0, -9. That'll be our y-intercept. Now, I'm going to point something out here, and this isn't a coincidence. But you see the -9 here for y? We also have a -9 up here. And that's not by coincidence. We'll talk about that in just a little bit. But we're going to finish here. We're going to graph this. Put that point up there. So if we graph this function, now for 3 and 0, starting at the origin, we'll go to x is 3, But then y is 0, so that means we don't go up or down anywhere. That's going to give us our x-intercept here. And again, that's on the x-axis. And then for 0, -9, well, x is 0, so that means we don't go anywhere, we just stay. But then y is -9, so we drop down to -9, and then we draw our line. And then that's going to be our f of x is 3x minus 9. So any questions about that? That's how we can graph using x-intercepts. So the other thing to mention, you saw that our y-intercept is the same as this number here. And that's not going to be coincidence. There's a general pattern here. If we take f of x, and it's mx plus b, where m and b are constants, the number in front of x is something we call the slope. And then this number, constant number by itself, that is the y-intercept. Now, the bad news is the x-intercept isn't as obvious. But the y-intercept, we do get that one up front, which is kind of a nice deal. So for example, if we need to find the y-intercept, I'll abbreviate intercept for f of x equals 7x plus 1/2. Well, this number by itself is always going to be the b in the y-intercept. So our answer, 0, b for the y-intercept, it'll be 0, 1/2. We don't have to do any computations where we let x be 0 and then solve for y. Don't have to do that at all. You don't have to. You can just read it off right there. I'm sorry. Yes, let x be 0 and solve for y. So let me show you another one. The point here is that the sign is going to follow with the number. So once again, this number is going to give us our y-intercept, and it's going to keep the sign with it. So 0b will be 0, comma, -2. It'll keep that minus sign. So questions about that? Now with slope, it's really the same thing. You're going to read off the number that appears on the x. Now you got to be careful. And this is going to be true for y-intercept also. Let me show you. So let's say we have something like this. find the slope and y-intercept. Now, a key thing we want to do, we want to make sure we solve for y first. When we solve for y first, this is called standard form. Actually, no, I'm sorry, not called standard form for a line. We want it in this form. Technically, it actually is, and this is standard form for a line, but well, close to it. But we want to make sure it's in this form to read the slope and the y-intercept directly from the equation. We want to make sure it's in y equals mx plus b form. So to get y by itself, we'll add 4x to both sides. And you could have had 12 plus 4x. That would be okay too. You're going to get the same result. Next, what we're going to do, we're going to divide both sides by 2. Again, the opposite of multiplication. And we're dividing the entire side. You might remember this from working with formulas. We have to divide the entire side. Now, what do we do with this? Well, we want to simplify this. We're going to get 4x plus 12 over 2. Now, here's a little tip. This is a trick. In math, when you ever have something like this, say a plus b, in fact, it could be minus also. Whenever you have something like this, you can rewrite it like this. The c will divide into the a and divide into the b. So what that's going to do for us here, we'll get y is 4x over 2 plus 12 over 2. And then what you can do is divide the 4 by 2. That's perfectly fine. You'll get 2x, and then the 12 divided by 2 is 6. So finally, we've got it in y equals mx plus b form. So now we got to figure out the slope and the y-intercept. Well, the number here, that's the b in the y-intercept. So 0b equals 0, 6. And then the number in front of x, that's the slope m. And in this case, it's equal to 2. And so our slope m is 2, and our y-intercept is 0, 6. So any questions about that? All right. So we just sort of got into slope now, and we've talked about y-intercept. And if I'm going too fast, please let me know. I might be erasing too fast. For slope, it can be a little tricky. There's a few examples that can show that slope can be a little tricky to identify. Now let's say we have something like this. Now again, the slope is going to be the number attached to the x. So mx in this case is negative 3x, and the slope is just the m. We're going to ignore the x. So the slope will be negative 3. And again, when we state the slope, we're going to ignore the x. We use it to identify where the slope's going to be. So the number attached to x, that's the slope. But the x itself, when we give slope as an answer, at the end we'll remove that x and say the slope's negative 3. Well, all right, well, slope is just the number attached to the x. So what about something like this? Well, in this case, mx appears just to be x, but technically it's 1 times x. So again, when you have a variable by itself, there's an invisible 1 in front of it. So this means the m that's attached to the x here, that slope is 1. So let's say we have this. Let's say our equation is negative x plus 3. Well, here are the mx, and that's where we look for the slope. We look for what's happening with the x. It's negative x. But you can rewrite this as negative 1x. And now you can see the m. The m is going to be that negative 1. So m will be negative 1. Questions about that? So a couple more sort of peculiar slope examples, just because slope can sometimes be a little tricky to identify. But if you have something like this, ¾ x, and this is a plus 2 here, a little more 2 there. So again, mx, that's 3/4 x. So the slope m is 3/4. So it can be a fraction, it can be a decimal. Now, this is something you probably won't see in the homework, but just in case if you do encounter it, if you see this, this can be rewritten as 3/4 x. You can rewrite it like that. And so what happens is 3mx is 3/4 x. And once again, m is 3/4. So same slope, but it can look a little different from line to line. Questions about that? Now, there's more to this we're going to get to. Actually, we'll address it right now. So a key thing with slope is we like to express slope as rise over run. So I've pointed out what slope is looking at the equation. What is it really for a line? Like, what is it describing? Because we know what the y-intercept is. We know what the x-intercept is. It's where you're crossing the x and y axes. But what is slope is just a concept. Well, it's a way of measuring an incline. So we have a run. We have a rise. And let's say this is part of a line. So this line keeps going on forever and ever. But we just take a portion of it. Well, the slope m is the rise over the run for your line. So let me give you some examples, not so much with lines, but with skateboard ramps. And if not skateboard ramps, bike ramps. So let's say you have something like this. And you have a run of, say, 10 feet. And you have a rise of 3 feet. And the key thing here, when we talk about rise and run, we're always thinking of going from left to right. So as we go from left to right, as we go up this ramp, we're going to travel horizontally 10 feet, but we're going to rise up vertically 3 feet. So the slope, which is rise over run, it's going to be 3 feet over 10 feet. And you can actually cancel the units here if you would like. You're just going to get 3/10 because this won't reduce any further. So any questions about that? So let's say we have a different ramp, and it doesn't have to be for things like skateboards or bicycles. We could be talking about a ramp we put in, you position behind a large truck. And if you're going to unload a truck, you might see something like this. So this could be 20 feet. This might be 5 feet. And again, when we evaluate slope, we're going to evaluate it left to right. So here's the thing. Again, it's rise over run. Now the run is going to be positive, so that's going to be 20 feet. But in this case with the rise, we're going to get a negative rise or a fall. And here's the reason why. As we go left to right, we're going to travel 20 feet horizontally, but we're going to drop down 5 feet vertically. So as we go left to right, we drop. So that's going to be negative. And then the feet can cancel out. And this will reduce to -1 over 4, or as we typically write it, we put the negative in front of the entire fraction. We get -1/4. So questions about that? So what does this have to do with the function? Well, you can see rise over run in the function. And it depends how you look at m. So let's take a function like this. Now, if we're looking for the slope m, it's the number attached to this x. So that's going to be 2/3. But it's going to have a rise and a run. So we're going to get a rise of 2 over a run of 3. So that's how we can read rise over run off of a function. Now let's say we have something like this. We had a -1/4 recently. Now, in this case, the slope, m, again, it's the number attached to the x, -1/4. But what we're going to do, we take the minus sign, and if we're looking at our functions as always going left to right, we'll move the minus sign to the 1. And so we'll get a rise of -1 and a run of 4. And that's, again, if we're always going left to right. So a rise of -1, that actually means we're going to fall 1 unit. Now, where this gets a little tricky is when you're dealing with whole numbers. So if you have something like this, your m, which is your slope, is going to be 3. But you can rewrite this as 3 over 1. So that gives you a rise of 3 and a run of 1. And it'd be the same with negatives also. If you have f of x equal to, say, negative 2x plus 7, well, again, the slope's the number attached to x. So m would be negative 2, or negative 2 over 1. So a rise of negative 2 and a run of 1. And again, a rise of negative 2 means we'll drop 2 as we go from left to right. So, okay, we can break, run. Well, let me do a couple more little tricky ones. And then what's the point of this? Why break slope into rise or run? Well, there's method to the madness, and it goes back to graphing lines. Let me show you another couple, it could be tricky examples. Now for this one, again, there's an invisible 1 in front of the x. So that means the number in front of the x, the m, is equal to 1. So, and again, I'm just going to state this from the previous example. Remember mx, which was x, and we called that 1x. So this meant m was equal to 1. So that's just going back to that previous example. So for m equal 1, we're going to rewrite this as 1 over 1. 1 is just a whole number. So for this one, rise is 1, run is 1. Now, finally for this one, and then we're going to bring this all together back to the idea of you need 2 points to graph a line. Now, in a previous example, we saw that mx looks like it's minus x, because the number attached to the x, that's always the slope. But this was really negative 1x. So this says the m, or the slope, is negative 1. And then, just like above, this is a whole number. So we can call this negative 1 over 1, or a rise of negative 1 and a run of 1. And again, a rise of negative 1 means a drop of 1 as we go left to right. We're going to drop down 1. So how does this help us with graphing these functions? Well, we need to generate 2 points to graph one of these linear functions. And we found out that we're given the y-intercept for free. So we couldn't do anything beyond that far as points go, free points. We don't get an x-intercept, we just get a slope. But the slope, using rise and run, we can generate a second point. It won't necessarily be the x-intercept, though maybe sometimes it is. But we can come up with the second point. And it works like this. The second point we take our y-intercept, we find 0, comma b. And here, I'll put this back up here. So we're working with f of x equals mx plus b. Then we take our slope and we break it down into rise over run. So we identify our y-intercept as 0, comma b. Then we take our slope, we break it into rise over run. And then the second point is going to be equal to the run, comma, b plus rise. In fact, I'm going to put a little, this might seem like it's kind of silly to put in 0 plus run. But we take the 0 here and the 0 here, the b here and the b here. We add run to the 0, we add b to the rise. And that's going to give us a second point. In fact, this will give you a second point if you have any other point on the line. It doesn't have to be 0 and b. If you had any other point on this line, adding the x coordinate to run and y coordinate to rise will give you a second point. That's a plus sign in there. So let me do an example. So any questions about this? So let's say we have y equals 3/4 x minus 2. Now, first off, we can generate the y-intercept. And we can read the y-intercept by this. We have 0, comma b is equal to 0, comma, negative 2. So that's going to be our first point. Now for the second point, we need to identify our slope. Now the slope, again, it's the number in front of the x. That's going to be 3/4. So you have a rise of 3 and a run of 4. And so now for our second point, we'll take 0 plus the run, comma, b plus the rise. And that's going to be 0 plus 4, negative 2 plus 3, or 4, comma, 1. So we have 2 points we can use to graph our line using the y-intercept, which we can read directly from the line, and then a second point we can generate using the help of the slope. I'm going to put these over here. So any questions about that? Is it okay if I erase this?
Yes.
All right. So I'm going to graph this line. We have 3/4 x minus 2. So 0 and -2, again, we start here. We're going to go to x is 0. Well, that's located at the origin also. So then we're going to hop down the y is -2, which is right there. Now for the next point, it's 4 and 1. So we're going to start at the origin, hop all the way over to x is 4, and then from here, hop up to y is 1. And then now if we graph these, my x-intercept might be off just a bit. Let's see, the x-intercept for now this you don't need to do. I'm just doing this off to the side to make sure I'm drawing an accurate graph. This will be 8/3. So yeah, it's about right about there. So that's going to be your line. Any questions about that? And again, you're just using these 2 points for 1 and 0, -2. So that's how you can use slope to come up with that second line or second point. We're given a first point with the y-intercept, but we can use slope to come up with a second. So the last thing to mention is to compute slope using points. There's another way you can think of the slope. First off, slope is the same everywhere along a line. So if you have a line, the slope in one place will be the slope everywhere else. It won't be any different. And then what it tells you, it's the rate of change of the line. So it's telling you really how quickly a line is rising or how quickly it's falling, again, as you go from left to right. And if you have a line you can compute the slope using 2 points. So to do that, I'm going to bring back that first picture we had of the triangle, and then we had sort of a line continuing on forever in green. And is it okay if I erase this?
Yes.
So I'm going to put this triangle on a rectangular coordinate system. So it's going on forever here, traveling on forever there. And we called this the run. And we called this the rise. Now, what we can do, let's say we have 2 points that are on this line. So this line's going through like this. In fact, I'll put some arrows here to emphasize that this goes on forever and ever. Let's call this point x2, y2. We'll call this point x1, y1. Now, what these little numbers mean, they're called subscripts. And what they stand for is, this is the y coordinate of the first point. This is the x coordinate of the first point. X coordinate second point. Y coordinate second point. So x2, y2, that means the x component is here, and the y component is over here. For x1, y1, here's the x component, and there's the y component. So those are the 2 points that are on this line. And what we're going to find out is that the distance between here and here, the base of our triangle, well, that's the same distance here. This is also the same distance of the run. And to compute this, you take the larger x coordinate and subtract from it the smaller one. Like if this is 3 and this is 5, then the distance between 3 and 5, well, that's 2. So if you're at mile 3 and you need to get to mile 5, well, the distance is 2 miles. So 5 minus 3 miles will give you 2 miles. Same thing for the rise. So if you're rock climbing and you're already 10 feet up and you need to get up to 30 feet to get to the top of the cliff. If you're going from 10 up to 30, that's a change of 20 feet. So to calculate that, you can take 30 feet minus the 20 feet. I'm sorry, the 30 feet minus the 10 feet will give you the 20 feet in between, or y2 minus y1. So any questions about that? So here's the slick move. Remember that slope, m, is rise over run. Well, now rise is y2 minus y1, and run is x2 minus x1. So this is the formula you can use to calculate slope from a line if you have 2 points. And we'll use this formula. We'll put it to work. All right. So is it okay if I erase this?
Yeah.
I can wait. Okay. So, for example, find the slope between the points 1, 2, and 6, 4. So one thing I recommend with this is decide on which point's your first point and your second point, and then label the coordinates. So this would be x1, y1 if we call this the first point, and this would be x2, y2. Now, if you wanted to, you could call this one x1, y1, and this one x2, y2. That would be perfectly fine. What you don't want to do, what would make the formula not work, if you did something like x1, y2, or y1, x2, when you mix up the subscripts, that's when the formula is not going to work. But if you kept it like this as x1, y1, x2, y2, this will be fine. Or if you said x1, y1, x2, y2, that would be okay also. So to compute the slope, we use this formula. It's always going to be y2 minus y1, x2 minus x1. And so what we'll get is 4 minus 2 over 6 minus 1. And again, the y2 and the y1, the x2 and the x1. So this will be 2 over 5, and that won't reduce. So the slope between those 2 points is 2/5. And that's it. So any questions about that? So there's one last thing to mention. I want to mention what are called vertical lines, horizontal lines, and then something about slopes in general, about the signs on slopes. So horizontal lines they're of the form y equals b. In other words, if you take f of x or y, I'll stick with y. Well, I guess I better stay with f of x because they use f of x in the text. They're the form f of x equals b. And you get this when slope m is equal to 0. And so what that causes is f of x equals mx plus b. This will be 0 x plus b, which is 0 plus b, or just b. So f of x equals b. And what this will look like if you graph it, you find the y-intercept. Zero comma b, and through that y-intercept, it'll draw a perfectly horizontal line that'll be parallel to the x-axis. So that's how you get perfectly horizontal lines. Another thing to notice, it only crosses the y-axis. It won't cross the x-axis unless it's sitting on top of the x-axis at the b equals 0, which is a horizontal line. F of x equals 0 gives you the x-axis. So those are horizontal lines. Any questions about those? All right. So for vertical lines, these are the form x equals a. And really, the thing with the slope, I mentioned this here, slope m is undefined. So if you have the point a comma 0 here, it is through this point that the vertical line x equals a will pass through. It's the point a comma 0 on the x-axis, and it'll be parallel to the y-axis, the other vertical line. So questions about that? So just a couple sort of fun facts about these horizontal and vertical lines. For horizontal lines, so let's have some sort of special notes. So you have f of x equals b. All points on this line have a y-coordinate b. And for vertical lines, all points have an x-coordinate, x equals a. So just some fun facts with horizontal and vertical lines. So the last thing I want to show you is just a summary of the slopes. So again, when we look at slope, we think of it in terms of left to right. It's usually what we do. And as we move left to right, if a line is doing this, we say it has a positive slope. If it's doing this as we go left to right, we're going to say it's falling or has a negative slope. And then we're going to have lines with zero slope and lines with undefined slope. So if a positive slope, we can have a negative slope. So what that will look like. This is what positive looks like. This is what negative looks like. For m is 0, we'll get a perfectly horizontal line, slope of 0. And then for m is undefined, we'll get a perfectly vertical line.
So you can graph undefined lines.
You can graph lines that have undefined slope. But that's about as far as you can go. An undefined line, you couldn't, as a line, if the line's undefined, you wouldn't be able to graph it. But there are lines with undefined slopes. Another thing you'll hear this called as, you'll sometimes hear this referred to as an infinite slope. Like this is 0 slope, and then you tilt it up, you get positive slope. And then if you really tilt it up, it becomes infinite. I've heard people say that, but I think the proper way to refer to it is undefined. And the reason it is considered undefined, is it okay if I erase this?
Yeah.
Yeah, if I'm going too fast, just let me know. Well, let's say I can keep this here. Let's say we have this. Oh, here, I'll erase it. I'll erase it. Let's say you have a vertical line, and for vertical lines, the x coordinates they're all going to be the same. So let's say we have, this is 5 and 0. This point is, say, 11. Oh, it wouldn't be that. It'd be 5 and 11. And this would be 5 and, say, -3. So let's say we try to calculate the slope of this vertical line. If x1, y1, and let's say we use this one, x2, y2. Well, then using our formula for slope, y2 minus y1 over x2 minus x1, or we'll get 11 minus -3 over, and then let's see, x2 is 5, x1 is 5, negative and negative becomes positive. 5 minus 5 is 0. And then you get 14 over 0. Now, when you get division by 0, that's going to be undefined. So this is a line. It does exist. But if you try to calculate the slope for it, you'll get division by 0 and it's undefined. So that's why that happens. If you take a horizontal line and you take 2 points off of a horizontal line and compute the slope, you actually get a slope of 0 because the y-coordinates will be the same for horizontal lines. But for vertical lines, you're going to get a division by 0, and that's undefined. So I hope that helps. Other questions?
I think that's all.
Well, that's it. That's what I've got for today. So, I mean, if you have any questions, let me know. Other than that, I mean, good luck on the homework. And again, send me a message if you have any questions.
Awesome. Thank you. I got through that